Okay, so this is Terrestrial Biomes. We're actually probably going to do 2 videos over this, 2 to 3, depending on how much I talk. This is dividing the biomes up into the different types of biomes. We're looking exclusively at the terrestrial or the land-based biomes right now, and looking at the characteristics of the animals that inhabit each. Okay, so we're going to define biomes. They're a major grouping, so it's based on region, looking at the plants and animals in that region, and we're looking at it at a global scale. So remember, we're not really focusing on anatomy or physiology or anything of specific animals, but rather what is that ecosystem, what does that biome as a whole look like. The big concept that you guys should be taking away from this is the distribution patterns of these biomes. Where in the world these biomes are located is correlated or connected with the climate and with the vegetation. And then most primarily with the rainfall. So you're going to find specific biomes. We'll draw a chart later. You're going to find specific biomes based on the amount of precipitation and the amount of rainfall. And then the vegetation type is going to come straight from that. Okay. So we need to look at the distribution pattern, where in the world these are found, how it's different in different places in the world. So like we can see deserts in different places, but how that varies based on where in the world you are. And then how the types of animals, so like a grassland in the US is going to be very different from a grassland in Africa, for example, and we'll take a look at all that. So these are the growth, so focusing specifically on vegetation in the biomes, looking at the vertical stratification. So if you start at the ground and then go up, increasing landscapes, like up to the top of a mountain, for example, how does the vegetation change with that stratification? And then what's the habitat, or the habits, the size, shape, characteristics of the overall prevailing plant species found in that area. Okay, and then you need to look at the animals. You need to look at the physical characteristics, you need to look at the plants, and then you need to look at the animals, especially the vertebrates, because that's what's generally most obvious. So we're going to focus on how they're adapted to those biomes. So not necessarily their specific anatomy or anything, but their anatomy as it pertains to the biome that they're living in. So for example, a fish is really well adapted to the water because he has a tail instead of legs. So stuff like that. Some of it is that obvious and some of it not so much. These are the 5 major biomes: deserts, forest, grasslands, tundra, and aquatic. Aquatic we're going to deal with later. So we're going to look at the at least the first 4 for the terrestrial unit, and then we're going to divide up these videos based on time, and so we're just going to keep going, and I'll finish the others in a second video, just kind of break it up for you guys. Okay, so a desert biome is about 1/5 of the Earth's surface, and it's again, the prevailing thing is the precipitation. So rainfall is less than 50 centimeters a year. So that is the definition of a desert. Rainfall is less than 50 centimeters per year. Most deserts occur at low latitudes, but there are some cold deserts that occur at like in mountain ranges and basins, and occur at higher types of latitudes. We'll talk about those. The vegetation is very specialized, so there's not much of it, but what there is very well adapted to that small of an amount of rainfall, as are the animals. Okay, the soils in a desert have a lot of nutrients because there's nothing there to use it up. So there's not enough water for a lot of vegetation, so there's not a lot of vegetation to use up the nutrients, so they tend to be rich in nutrients. The climate of a desert, or the weather patterns, tend to be very abrupt and can be kind of violent, really. Fires or dust storms, and then it's all happening, very suddenly. You're out there in the blazing sun one minute, you're covered in a dust cloud the next, or it's downpouring rain, stuff like that. And then the temperature changes are very drastic. So when the sun comes out during the day, it's incredibly hot, but then it drops like 40 degrees and is really cold at nighttime. So that creates a big challenge for anything that's out trying to survive in that ecosystem. Okay, so this shows you geographically where the deserts are found in the world. So I would make sure that I took a look at this and could kind of list in my head at least where a couple deserts are. You guys all know there's a big desert in Africa. There's a smaller one closer to the west coast, to the west of us in the US, stuff like that. There's plenty in Australia. And then along the Central Asia, stuff like that. Okay, so this is looking at the mean temperature. Like I said, temperature and precipitation are going to be the key in looking at the different types of ecosystems. So it's showing how they're changing. It's showing both. This is great. So it's showing precipitation on one side, and it's showing temperature on the other side. So you see the difference there. Okay. So the different types of deserts. You're going to have what everybody pictures when they picture desert, which is a hot and dry desert. You can have a semi-arid desert. You can have a coastal desert, and you can have a cold desert. So the hot and dry desert. Temperature is the first primary thing. So in a hot and dry desert, the desert surface is more than twice the solar radiation received by humid areas. So like a tropical rainforest gets significantly less radiation than a desert surface does, and so they lose almost twice as much heat at night. So again, that's that huge temperature range that is so challenging for animals and plants that live in these deserts. And this should be negative 20 to 25 degrees Celsius. The extreme maximum is down at the bottom. And then minimum temperatures, like I said, down to negative 18, negative 20. So it's overall a very big range in temperature. That's a challenge. Rainfall is very low, short bursts. Everything is rapid, like I said, in deserts. So you get a lot of rainfall all at once and then nothing for months. So because it's so hot and dry, evaporation is extremely high and therefore exceeds the rainfall. A lot of the time the rain will evaporate before it hits the ground. The lowest place in the world for rainfall is the Atacama Desert in Chile. The Sahara is also very, very low. And then American deserts are a little not as dramatic, as excessive as that. We're at about 28 centimeters a year. Okay, so the soils, they kind of vary. It depends on where in the world you are. From a coarse texture down to a really fine sand. Like the American deserts tend to be really rocky or gravelly. Coarse-grained because there's less weathering going on there. And then all the little stuff that's created, the fine sand that's created, is blown around. So plants are minimal. It depends, again, on where in the world you are. The American deserts have the little straggly-looking trees that don't look very healthy, but that's what they're supposed to look like. The cacti are very common in some areas, and then in other areas, it's little, if not nothing, around. So it tends to be ground-hugging shrubs, no grass for sure, because it needs a lot more water, and those short, really woody trees with not a lot of leaves. Okay, so this shows you some of the plants for a hot and dry desert, just to give you like mental pictures and to be able to create those food webs and look at those patterns. The animals tend to be nocturnal because it's nice and cool at nighttime. A lot of burrowing, plenty of invertebrates. Low biodiversity overall, but the numbers that are there are insects and spiders, so invertebrates. Small stuff eating those insects and invertebrates. And then everything stays protected during the day and comes out at night or at dusk and at dawn. And so these are a lot of your options for animals. So snakes and lizards for sure, tortoise, ants, the tarantulas are there, wasps, and then the few bigger stuff, like in a few places there's a bighorn sheep, we've already looked at those, and the coyote. Okay, so a semi-arid desert is your next type, and that is, if we're looking at temperature, not quite as crazy as the hot and dry desert, so it's a little bit smaller range. Doesn't usually have the drastic hot and cold that a hot and dry desert does. The precipitation is very similar, very, very low, but the plants are a little bit better because the less drastic temperatures help to keep that precipitation. So even though there's very low rainfall, the rainfall that does fall is actually more useful to the plants and animals than in a hot and dry desert. The soils are mostly sandy and fine textured, with a few rocky spots, low salt concentration, so low nutrients compared to stuff that gets, downfalls of water, and then still no subsurface water. The plants are more spiny, not a lot of broad leaves here because there's not enough water to support them, they'd shrivel up. So the adaptations they have are those leaves have been modified into spines, and that allows them to still work on the photosynthesis without having the big broad leaves. So these are your options, some examples for the semi-arid desert plants. And then the animals, they will move in a little bit more. A semi-arid desert, think about, is picture your hot and dry desert, a little bit calmer, a little bit less extreme. So it's a little bit easier for the animals to move around during the day. You'll see a few more moving during the day, but you still have a lot of burrowing, you still have a lot of nocturnal stuff going on. So very similar in types of animals, for sure. But you do see a few more, like the mountain lion and the rabbits and kangaroo rats. So there are a few more mammals and then larger animals than we would see in a hot and dry desert. The coastal desert, temperatures, cool winters, long warm summers. Temperature range is much smaller again. So you're seeing, the ocean effect keeps things a little milder than you would see if you were more inland. So you see that for sure. Rainfall is higher, not great, but a lot better. The soils are fine textured with more salt content. They're picking that up from the ocean right near them. Good drainage, fairly porous, still no water table underneath. The plants, extensive root systems, and then now we're starting to see more fleshy leaves, but they're really thick and very waxy. They have to be adapted to the salt in the air, so they have to be able to tolerate. So they can't be the really fine leaved stuff. So we see, again, you're seeing a few more leaves, but it's not big leaves. They're the short, thick, as opposed to the long, thin. The animals, pretty much the same plan. We see a few more of the amphibian type stuff, the toads and the frogs, salamanders, because they have a little bit more rainfall, so we can start to see that. So we see the options there, same general patterns for animals in a desert, coastal desert, or anything else. A cold desert, these are really interesting, one of the coolest, I think, personally. So you're in colder latitudes. You're up in Greenland or the Arctic, northern Canada, stuff like that, Iceland, and then down in the Antarctic. So it's still a desert because the rainfall is minimal. But you have more rainfall than the hot and dry for sure. And then you have snowfall, so it doesn't necessarily count as, it still counts as precipitation, but it doesn't help the animals because it's not water. Short summers, moderately warm. So this is not a desert in that it's hot and crazy. It's a desert because it doesn't get enough water. So most of precipitation is actually snow. There's very little rainfall, but there's plenty of snow. And then they get a lot of rainfall in the spring, and they have a very, very dramatic wet season, and sometimes in the autumn as well. The soil tends to be much more filled with nutrients because it has a little more rainfall, and that short summer, that's about all the plants aren't using up very much of it. Widely scattered plants, some sagebrush is most common, but again, most of it's under snow most of the year, so you don't really have a lot of even the shrubs or the short trees for sure. It's just very low-lying brush type stuff. Okay, so you see the cold desert, the algae and kelp a lot, lichens a lot, and then bryophytes. So it's that low-lying. I don't even know if I would call it brush. It's more like a lichen or a moss is what I want you guys to picture for the cold desert plants. The animal density is a little bit higher than most places. Everybody tends to be a burrower, even the carnivores, which is unusual. There's a lot of animals that move around, that visit for a while and then leave, so they might come in during the summer and all the animals come out. Hibernation is very common around here. So you might see a lot more of the smaller mammals, fewer of the insects because they don't like the cold weather as much, but more of the mammals because they can tolerate that cold better than the insects can. So notice that everybody is burrowing. Okay, so here's a typical food web for a desert biome. You have your plants at the bottom, insects, rodents, lizards, stuff like that, going up into snakes, bigger lizards, and the carnivorous insects. And then the larger predator, even the large predators are not really that big. A hawk or a fox, maybe an owl, not the big predators that we typically see at the top of a food chain. This type of area can't support that type of life. Okay, so we are going to move into the grasslands. Grasslands are characterized, this is your next biome. Grasslands are characterized, dominated by grasses. Not really very complex here. Not a lot of trees or shrubs. This is where you see the big herds of land animals because they have all the grass to eat. And then there's two different types of grasslands. There's a tropical and there's a temperate. So there's a savanna and a temperate grassland. So let's look at the savanna first. Savanna is the ones with the scattered individual trees. This is where you picture Africa when you think of savanna. The climate's the most important factor. Fires maintain an area, so fires kind of reset different places in a whole savanna over time and will renew the soil, renew the grass, and start that secondary succession up again. So there's a few different kinds of savannas that I'll just be able to recognize. I wouldn't go into too much detail on them. The climatic, the edaphic, and the derived. So just kind of recognize it in case somebody asks you a question about it. But I wouldn't stress too much about being able to differentiate. So this is your map for savannas. Notice they're right around the desert. You typically have the desert here and then the savanna around it, for example. The precipitation is decent. They tend to have a wet season and a dry season for a lot of the grasslands. So you'll have that rainfall that's concentrated in half the year, give or take, and then a long period of drought, and that's when the fires happen. So that it kind of resets over and over again. Okay, so the reason that rainfall, or the reason that it's a savanna rather than a forest, is because that rainfall is so concentrated, and the grass grows a lot faster than trees. So you can have grass that resets every year, and then dies every year at the end of the rainy season when there's a drought, as opposed to a tree can't ever get started enough to survive. Soil is very porous, thin layer of humus, which is not the stuff you eat, but the organic portion at the top of the soil. We'll talk about that later in the year. And it provides the nutrients. So we have higher nutrients here than we saw in the deserts. The plants are characterized grass. It's all high grass, 3 to 6 feet tall. May have a few trees, may not. It's really, there's like pockets of trees and then it is open for a while. But the dominant plant life in the savanna is grass. Okay, so in the wet season you have tons and tons and tons of animals. Not necessarily really high biodiversity. I would say maybe medium biodiversity. But you have very high biomass. You have lots and lots, a few species, but lots and lots of each species. This is the big herds of animals that come through and graze on these grasses. So the rainy season is, a surge of new life. And then the animals will all time everything so that they're giving birth to their calves right at the beginning of the rainy season, so everybody gets big enough, and then can get through the drought when they're a little bit older. So the animals here, make sure you're familiar with the fact that it's very specific. The species that you see are very specific to, excuse me, to an area. So you'll see, the giraffe, zebras, buffaloes in one place, and then different species in other areas. So most of the time we picture the savanna with the giraffe, zebras, and stuff, but there's savanna on Australia that would have the kangaroos and the gophers and the ground squirrels. So there's very different species in different savannas around the world. Okay, so these are all your options. Lots and lots of options for savanna. Really cool food chains. I'd love to go there someday. It'd be a lot of fun. Okay, and then the temperate grassland is a little bit colder climate, so now we're moving up into the temperate zone. Grass is still the dominant vegetation. We still have the seasonal wet and dry cycle. Occasional fires, not as bad as the savanna. So the precipitation, again, is usually in the late spring, early summer, and about average amount of precipitation. But it's that long period of drought that makes the grasslands different. So again, we see the precipitation and the temperature overall for both of them, so you can follow what's going on there, and you see that spike in the middle of the rainy season for both. Much smaller areas for temperate grassland, but again, you notice that it's around the desert. So remember the deserts, we saw the savannas, desert up here, savanna down here, now we see desert here, temperate grassland here, so they tend to be following this pattern. The range is very large over the course of the year. Summer temperatures are really hot, winter temperatures really cold, so it's a lot to get used to. So this would be where we see in the U.S. like the bison and buffalo and stuff. Soil is deep and dark, very fertile. That humus layer, however you want to say it, is really, really dense and nutrient rich. And then the roots hold that soil together and provide a good food source for the living plants as well. So everything is just focused right there at the surface. Different species of grass. The fires reset everything, so that prevents still the trees and the shrubs from invading and becoming established. So you have, a tree here and there, but for the most part, it's still dominated by the grass. So here's a whole bunch of the grasses, the plants that you would see. Notice that you see a lot of the flowering plants coming in right now. And then the animals, depends on where in the world you are, again. So make sure that you're comfortable with a grassland in the U.S. is going to be very different than a grassland in India, because it's going to have totally different animals. So, India might have a rhinoceros, whereas here we're going to have a horse or a bison. So there's this whole food web. You really have to look at where in the world you are. You can't just say temperate grassland and have this stuff mixed together. Okay, and I think we're going to stop there for our first video.